Hello, my fabulous fifth graders. Today's lesson is on the simplest form, and our I can statement is I can reduce fractions to their simplest form. This should be a bit of a review. Let's see what we've got today. In order to simplify a fraction, we need to find the greatest common factor of both the numerator and the denominator. So here in this example, Angie has a vertical jump height of 12 inches, while Holly has a vertical jump height of 22 inches. So Angie's vertical jump is 20 seconds of the vertical jump of Holly. We're going to write this fraction in its simplest form. Our very first step is to list all the factors of both the numerator and the denominator. We're lucky here, they've listed the factors for us. All the numbers that can divide evenly into 12 are 1, 2, 3, 4, 6, and 12. And for 22, all the numbers that divide evenly into 22 are 1, 2, 11, and 22. So we can see here that the greatest number that we find on both lists is 2. The GCF of 12 and 22 is 2. Our second step is to divide both the numerator and the denominator by the GCF. This results in an equivalent fraction. Remember, equivalent fractions have the same value, they just have different names. Remember when I taught about my pizza party where I had 1/2 of a pizza, but Mr. Dodge had 500,000 1/millionths of a pizza? We both ate the same amount of pizza, even though we had different names. So here we've got 12 20-seconds. And we are going to divide both the numerator and the denominator by 2. I want to point out here that they've put this 2 over 2 inside this, what I like to call the big 1. That's because whenever we divide any number by 1, the result is itself. So 12 divided by 2 is 6. 22 divided by 2 is 11. So now we've come up with a fraction 6/11. Now, is this in its simplest form? How could we check? Well, we have to see if we can find the greatest common factor of, again, our numerator and our denominator. So the factors of 6 are 1, 2, 3, and 6. The factors of 11, well, 11 is prime, so I know it has 2 factors, 1 and itself. Now let's check out this list of factors. I see that the greatest number on both lists is 1. When that happens, we know that this fraction is at its simplest form. When the only factor they have in common is 1, then we know that it is as simplified as it will go. So Angie's vertical jump is 6/11 of Holly's vertical jump. We can check by using a model. Our first fraction was 12 out of 22. So I'm going to shade in 12 of these 22 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Next, I'm going to use this model to shade in 6 of these 11 pieces. 1, 2, 3, 4, 5, 6. When we compare these models, we see that 6/11 and 12 22 are the same value. They are equivalent fractions, but 6/11ths represents this fraction in its simplest form. Here's another example. They ask us to write 18/30ths in its simplest form. Here, they tell us to divide the numerator and denominator by the same common factor and continue dividing until the fraction is in its simplest form. This is an idea you can use if you don't know or don't have time to find all of the factors of both the numerator and the denominator. I can look at 18 and 30, and I know right away both of these numbers are even. So without even listing all of the common factors, I know that 18 and 30 at least have 2 as a common factor. So I could divide both the numerator and the denominator by 2. Here, 18 divided by 2 is 9, and 30 divided by 2 is 15. Now I have 9 and 15. Well, I can look at both of these numbers and think, are they in their simplest form? Well, I know that they're not even, so 2 cannot be a factor of both of them. But I look at them, and because I know my math facts, I can tell right away that 3 is a factor of 9 and 3 is a factor of 15. So I can divide the 9 and the 15 by 3. I know that 3 is a common factor of both of these numbers. 9 divided by 3 is 3. 15 divided by 3 is 5. And since 3 and 5 have no common factors other than 1, we're going to stop dividing. So 18 divided by 30, written in its simplest form, is 3/5. Let's try a couple more examples. I'm going to try these 2 examples with the 2 different methods we've already discussed. The first method is listing all of the factors of the numerator and the denominator. So, I've got 4 and 6. All of the factors of 4 are 1, 2, and 4. All of the factors of 6 are 1, 2, 3, and 6. Now I can see that the GCF, the greatest common factor of 4 and 6, is 2. I can divide 4 and 6 by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. The simplest form of 4/6 is 2/3. These 2 fractions are equivalent fractions. They have the same value. It's just that 2/3 is the simplest name we have for that value. Now I'm going to do the second example with the second method that we learned. Instead of listing all of the factors of the numerator and the denominator, I'm going to look at the numerator and denominator and notice these are both even. Since I know both of these numbers are even, I know for sure that both of them will have 2 as a factor. Since they both have 2 as a common factor, I can divide both my numerator and my denominator by 2. 2 divided by 2 is 1. And 12 divided by 2 is 6. Now I can have to check this fraction, 1/6, and think, is that in its simplest form? Well, I know that 1 does not have any other factor than itself, 1. So I know that 1/6 is in its simplest form. The simplest form of 2/12 is 1/6. 2/12 and 1/6 are equivalent fractions. They have the same value, but 1/6 is the simplest name we have for that fraction. Let's use what we've learned about simplest form to solve this word problem. Here, Nadia has read 36 pages of her 75-page book, and Harper has read 60 pages of his 125-page book. Who has read the larger fraction of their book? Let's see. Nadia has read 36 out of 75, while Harper has read 60 out of 125. So I'm going to try both of the methods that we've learned to simplify these fractions so that I'll be able to compare them. I'll start with 36 75ths. I'm going to list all of the factors of both the numerator and the denominator. 36 has factors of 1, 2, 3, 4, 6, 9, 12, 18, and 36. Wow, that's a lot of factors. 75 has factors of 1, 3, 5, 15, 25, and 75. When I look at this list, I can see that the greatest number that they have in common is 3. I'm going to divide both the top and the bottom by 3, also known as our big one. When I divide both 36 and 75 by 3, 36 divided by 3 gives me 12, and 75 divided by 3 gives me 25. Now, let's try 60 125ths. Now, it took me a long time to write out all the factors of 36 and 75, so I know that it would take even longer to write out the factors of 60 and 125. So I'm going to try my other method. Instead of listing out all of the factors, I'm going to look at both my numerator and my denominator, and I'm going to think, what do they have in common? Let's see. I know that both 60 and 125 would have 1 as a factor. 125 is not even, so they couldn't have 2 as a common factor. 3 is not a common factor because it's not a factor of 125. 4. How about 5? I'm going to try 5. So I'm going to divide both the top and the bottom by 5. I know they both have a factor of 5. And 5 over 5 is also known as my big one. When I divide 60 divided by 5, I get 12. And 125 divided by 5 is 25. So when I put both of these fractions in their simplest form, I can see that they are equal. 36 out of 75 and 60 out of 125 both equal 12 25ths. Nadia and Harper have read the same fraction of their book. Brings us to the end of today's lesson. For your W part of your WISC, our topic is simplifying fractions to their simplest form, and our I can statement is I can reduce fractions to their simplest form. Go ahead and press pause now if you need another second to write this down. This is your summarizing question. In complete sentences, I would like you to explain how to find the simplest form of any fraction. I showed 2 different methods in this video. You may explain one or both, but please explain in clear, concise, complete sentences. Again, press pause now if you need more time to work on this part of your WISC. Finally, here is the Q section of your WISC. There are 3 questions, 3 fractions that I would like you to find the simplest form of. You may use either of the methods I discussed in this video, but I'd like to see the simplest form of all 3 problems. Finally, I'd like you to come up with at least one problem for your table members to solve that illustrates what you learned in this video. I look forward to seeing what you come up with in class today.